Okay, so a second example video for how to do a bond enthalpy calculation. So, what have we been given? We've been given some data over the side, bond enthalpies in kilojoules per mole. That's important. We need to know they're in kilojoules per mole because we need to use the units at the end. Hopefully we've been given enough data to do the calculation. You always hope that. So let's have a look. What are we dealing with? Well, we've been given a balanced equation, which is always nice. But with this one, we don't have, at least in this example, we don't have it drawn out. So we need to write display formulae. Okay, so let's look at drawing some display formulae. Right, so I'll put my arrow in. What have I got on the left-hand side? I've got diatomic hydrogen. Now, I should know that hydrogen has a single bond. And if I didn't, I've got the clue over here because I've only been given data for a hydrogen single bond. Okay, so I've got one of those. I've also got one diatomic chlorine. Chlorine in group 7 means it's only going to make one bond. So again, this diatomic only has a single bond. Again, I can get that clue over here. What else have I got? Well, I've got 2 lots of HCl. Well, I could write my HCl, which again has a single bond, and put a 2 in front of it. But personally, I don't like doing that. The reason I don't like doing that is I like to keep a visual track of all of the bonds that I've got. So I'm actually going to write it out twice. Okay, so how do we actually go about doing the calculation? Well, delta H. What's delta H? Delta H is the molar energy change. As you go further through science, you'll probably end up calling it a molar enthalpy change, which is a little bit more accurate, but for now, we'll just call it energy change. Delta H equals sigma BB minus sigma BM. Now, that's really cool for just an aide-memoire for remembering it, but in an exam, we need to write things out in full. Equals sigma. Sigma meaning sum of bonds broken minus sigma bonds made. And what we're going to do is we're going to split our little calculation up. Over here on the left hand side, we're going to deal with sigma BB, which, as I said, I shouldn't write. Let's do sigma bonds broken. If you're going to do a job, do it properly. Sigma bonds broken. Okay, so sigma bonds broken, that's these guys up here. So I have one lot of the HH bond. Why am I saying one lot? Because I've only got one of it. I can't see any more. No more than that. Plus one lot of the Cl bond. Okay, what are those values worth? One lot of 4, 3, 6. And one lot of 2, 4, 2. Which equals 6, 7, 8. Now I really should put my units in all the time, so this is kilojoules per mole. So this is the bonds broken. That's the amount of energy put in to break the bonds in the reagents. As I think I've said before in a previous video, if you have bonds that appear on both sides, just break them on the left and remake them on the right. It's a zero-sum game. You end up with the same figure. It's just easier to keep track of what's going on. So what else do I need to know? Sigma bonds made. Well, what have I got up here? I have this bond and this bond. Well, what are those bonds? They are both HCl single bonds, and I've got 2 of them. So that's all I've got up this side. So I've got 2 lots of 4, 3, 2. If you're wondering again where I'm getting these numbers from, they are up here in the data that has been very kindly given. If you find yourself trying to do a calculation that you don't have data for, you probably made a mistake in your diagram. Okay, cracking on. What does that give us? That gives us 8, 6, 4. Let's see if I can squeeze in the units here. Kilojoules per mole. Cool. That is the energy given out when the new bonds are broken. And now if I have a quick look, I'm giving out more energy here than I'm taking in here. So it should come out as exothermic. Let's just double check that. Delta H equals sigma, and I'm running out of room here, so I'm going to write BB minus sigma BM, and I can probably get away with it because I've written it out in full up here. So delta H equals 6, 7, 8 minus 8, 6, 4, which equals minus 186 kilojoules per mole. Again, this negative sign here is telling me it is exothermic because I have more energy given out. This is energy given out, making the new bonds, than energy taken in, breaking the old bonds. It is an exothermic reaction. Job's a good one. Again, run this through for yourself, see if you get the same answer. Also, make sure you label everything fully. Bonds broken, sigma bonds made. Write out delta H in full. Delta H is sigma bonds broken minus sigma bonds made. And don't forget your units. Cool.